Hello and welcome. My name is Michael Carty and I'm an applications engineer at EWI. I will be presenting on behalf of the project team on the topic of robotic arc directed energy deposition additive manufacturing coupler build demonstration. At this time, I would like to acknowledge that the content being presented was developed as part of the National Shipbuilding Research Program Advanced Shipbuilding Enterprise Research Announcement Project 2019-375-004. The coupler build is a high-strength steel coupler that was produced using 0.045-inch diameter MIL 100S wire on an HY80 build plate that was 1 inch by 12 inch by 12 inch. The dimensions are shown in the picture in the upper right. The base was 8.63 inches in diameter and transitioned to 6.63 inches in diameter at the top. The build was approximately 6 inches tall and had a 30-degree transition angle. The system used for this build was a single-arm Motoman MA1440 6-axis robot that utilized a Fronius TPS 500i welding system that is capable of GMAP, GMA, and CMT. This system also included automated interpass temperature control. Lastly, by using a single-axis MH96 positioner, it is also capable of building single or double-sided build platform structures. This pictogram is courtesy of Autodesk and shows the 10 additive build categories. These increase from complexity from 1 being linear extrusions to 10 being artisan. The coupler being produced is build category number 2. This pictogram is again courtesy of Autodesk and it shows the digital data workflow in 7 steps. Step 1 introduces the CAD component. Step 2 is where you preform or change the component for AM. Step 3 is where you set up the component in PowerMill. In this case, it is set up in a chuck. Step 4 is where you introduce the trajectory. Step 5 is where you decorate or add specific process conditions to the trajectory. Step 6 is where you sequence the build. Here you can add items such as wire clipping or active cooling. And step 7 is where you simulate your build and output the NC program or robotic code. Here are the couplers presented in the digital data workflow. In step 2, the transition angle was changed from 45 degrees to 30 degrees. In step 6, a subroutine is called to check the interpass temperature and cooled as necessary. Here the build strategy is presented. It is a 3-axis build on a flat build plate. 3 beads per layer with staggered integral starts and stops. 2 DED GMAP procedures were utilized for this build and meshed into 3 build models to create a master build model. The design and path plan are shown in the top, and the simulation model and cell are shown in the bottom. Here the final build is shown in the lower left. The build had very consistent build profiles and visually appeared to have complete fusion. This is shown up close in the lower right. After completing the build, the coupler was visually inspected to the intent of MIL Standard 2035 and no defects were found. A metallographic section was removed as shown in the bottom left and no notable discontinuities were found. The metallographic section is shown in the bottom right. Thank you.